Ah. Hello everyone. Sorry. Hello everyone. Welcome back to the channel. So today in this video we will continue the part two uh, of the previous thing which we were doing, which was coding, and yeah, I'm a little under the weather. I'm not feeling well, so I'm gonna cover up my face while working on the code. Well, I might not. I'm not sure because I do have to show you the thing on the camera. So, well, yeah. So let's get started. I have to continue and I have to see what I was working on because I have forgotten about it. So, what is it? Okay, okay, okay. Right. The register part. Okay, yeah. Let's continue. So, uh, we were working on the register change bit, register get bit, register send. Bad. So just I'm gonna make a clean build. Compile. So now I was supposed to open the file. Reveal in Explorer. Yeah. So we have power management one. We made a thing for power management one. We make a thing for power management two. Make a thing for power management two. So we have register.get, we get the power management too, but we are not putting it in the flag dot sleep equals to. Okay, well, actually I don't need this because what are the stuff in power management too? We have LP specify the frequency of wake ups during accelerometer only low power mode. Okay. Mm, okay. Uh disable X, Y, and Z. So, for what I understand is that we are just disabling the output for one particular sensor. Like, one particular axis of this sensor. Like for accelerometer, we are just disabling the acceleration for x-axis, y or z. So I believe, uh well, I am not too sure about the wake up cycle or wake up frequency, like, well, to create a flag separately for it. But I do need to add a power management bitmap for, we rename it to 2 and clear all of these. So what is our first? Disable YG XG, right? Then what do we have? AVL disable ZA YA XA. Then what do we have? LP wake up control. LP underscore wake up CTR RL underscore 1 0 and 1 wake control. So this will be second bit of that. So 0 1 2 3 4 5 6 7. It's like 0 1 2 3 4 5 6. So yeah, 7 bit counting from 0. That's good. Uh, we do have two of these now. I don't remember. Like, let's save that and register bit. Yeah, we need to do this case PWR underscore MGMT2. Then, well, I'm just gonna copy and put it over here. Okay, change bit. Power mana. I just need to change to 2 to 2 to 2. Right. Hmm. Let me just check. If the state is set, then it should set the position. If it is not, then it should not. It should reset basically. Yeah, good. And we do break. We already have default, so we have to register set for the change bit and a register bit. Mm, wait a sec. Init. I don't want init. A register change bit, get bit, send bit. So for the send bit case PWR MGMT2, we have temp data. Nice, nice. Well, good for me. Break. Sometimes it's better to have AI because I literally skipped couple of steps to write down manually. So I'm just gonna verify if it is right or not. So what I want is to set the address of the first position of this temp data as this, and the second as the data we want to add, which will be registered. Nice. And we send the data. Good. Now let's see what are the other. I don't remember which ones were the one I have to config. Like which were my bad, very bad. Sorry. Which one of the registers which I was supposed to configure, but I do have some uh points I have written. Okay, so we need to make a config, gyro config, extraction config, user control. We already did power management 1 and power management 2, and we have then optional configuration in pin interrupt pin config, interrupt enable, and interrupt status. And yeah, so those things, so we can do that on the later stage as well. So first, let's just go complete four other register. Let's go to a register map. Which one was this register? 1A. We have FIFO mode, exit sync setter, and DLPF config. Okay, so it's binary 26 configuration. So exit sync setup, enable fsync pin to be sampled. So we have fsync bit location to capture short probes. This will be done such that if fsync toggles, the latch value toggles but won't toggle again until the new latch value is captured by the sample rate probe. Okay, so you attach a probe for that. Like technically I am not exactly sure how this guy works, so what are we gonna do? Or we are gonna just open the data sheet to see the fsync feature. I haven't used it, so that feature actually, so I would like to know what it is. Not FIFO center data, sensor data, not this one. Well, ooh, my bad, sorry. Well, uh, the light is too much for me, so I'm just gonna drop down the brightness. Tired, not tired actually. I am a little sick. I'm fresh, but my face look like this just because I am a little sick. So yeah. Okay. What should be done? I want to check this. Okay. Anyways, I'm not gonna be personally using this feature, but I'm just writing this thing so that the people who wants to use this feature can easily configure it. Uh, so we also have the DLP to be used. This one is important for us because this will also help us to set the gyroscope bandwidth, delay, and like what frequency we are gonna use for it, and for the temperature sensor as well. So we have F choice. So DLP config, we have DLP config or F choice. F choice always comes under gyroscope configuration or accelerometer configuration. But if those, so for the DLP config to be used, F choice must be set to 2B11 as it is F choice, or F choice B is equal to so my bad. So F choice is an inverted of sorry, F choice B is an inverted of F choice. If you read this, the DLP F is configured by DLPF underscore config when F choice underscore B is to be like the bits, both the bits are 0, the gyroscope and the temperature are filtered according to the value of DLP config. And the F choice underscore B as shown in the table below. Note the F choice mentioned in the table below is the inverted value of F choice B. So henceforth, if it is if it is set to be set as both the bits as 0, we need to set both the bits to 1 over here. So just a little complicated shit, but it would be work fine. It will work fine. So we just need to make a configure. We go into the header file. I'm just gonna add you an 8 config register. We are gonna be dealing with config register. Set this up, and I'm just gonna copy and paste at the top. So well, I'm not using a type def because I'm just using as a numerator kind of thing. Well, config. So what do we have? We have the 7-bit as reserved. Okay, I'm just typing it out. Then we have first 3 bits as DLP config. So I'm just gonna delete this section and say DLPF, right? DLPF underscore CFG. Well, underscore 0, 1, and 2. Then what do we have? Exit sync setup. EXIT, EXT, sorry. External external SYNC underscore set underscore 0, 1. So how much is it? This is also a 3-bit, and I'm just gonna copy and paste and uh, do it 2. And we have FIFO mode. FIFO underscore mode. So we have 0, 1, 2, 3, 4, 5, 6. Wait a second. What? 0, 0, 1, 2, 3, 4, 5, 6. Wait. Am I missing something? So this is 3 bits. And if I'm not wrong, this is also 3 bits. Oh, my bad. My bad. We are absolutely correct. It's a 8-bit register. So why am I getting confused? My bad. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, if I start from 1, 1, 2, 3, 4, 5, 6, 7, 8. So that's good. I was not sure. 0, 1, 2, 3. Mm-hmm. Just a second, guys. Uh, was this right? Give me a second. Give me a second. Okay, let's get back to the work which we were doing. Actually, I was doing so. We have config register. I'm just gonna go ahead and make the next register as well. So we the next one is gyroscope config. So I'm gonna create the same thing. Oh my bad. Duplicate and go at the top. Our gyro UI RO. Do we have any reserved choice? Okay, we have number two as reserved. Okay, we have F choice B, F choice B, 0 and F choice underscore B underscore 1. This is bit first. And the third reserved. What else? Gyro FS select full scale select. We do this DM. So how much 0 and 1 we have? I'm actually gonna use about 0 and 1. Then we have ZGST. This is our for self test. ST. Well, the rest should be automatically. Yep, done. So same way I'm gonna create it for the second configuration, which is accelerometer config. So let's go ahead and create one more. So the essential ones are already done. Wait a second. ACCEL is the one I was using. So what do we have here? Let's check it out. So we have reserved for 7 to 4th, 4th bit to 7th bit. So we get it. We have 3 bits for ADLP config. So let's get this done. ADLP config paste underscore 0 1 and well underscore 2. Okay, then we have the third bit as ACCLF choice B. I'm just gonna copy. Wait, about ACCLF choice B, and we have reserved for rest of the stuff. So reserved 1, reserved 2, reserved 3. So do we have 3, 3, 6, 3, 3, 6, and 7? Done. Wait, 0, 1, 2, 3, 4, 5, 6. last one as four. So it's 4 to 7, 4, 4, 5, 6, 7. Done. Ta-da! Let me check the value, which is 7, 6, 4. Good. Sorry. Um, Now we can move ahead and uh, get these data, but we also need to use UN 8, 8 underscore E. It will be GYRO gyro by G 8 ACCL underscore CYNF by G. Okay, we have two registers set, and now we can use it over here. So I'm gonna make case. Actually, these are the two last configurations. So I'm just gonna make a copy of this guy and push it at the top. Make two more, and now I can change it. Config one at a time. Let's go. Dot config state of config space, and then again dot config. So we changed it gyro config dot gyro config dot gyro config or gyro config. Nice. Oh, my bad. Whether if you are not able to see the lower things, small things behind my camera frame, so my bad. Let's continue to do this guy. The next one is acceleration config, acceleration config, acceleration config. So here we go. So why is this guy? Let's try to compile. Okay. Oh, my bad. ACC acceleration config. My bad. The case has been resolved. Still, previous reserve was here. Okay, so this will create an issue, I guess. So, uh, do I need to do a type def for it to be changed? Do oh well, it's gonna give an error again because I did not have something which was supposed to be. Hmm. Well, I forgot to add a bit underscore map. Pa- pum, 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 pum. Yep, it's gonna create an issue. So what I'm gonna do is first move okay. By removing this, I'll make sure one thing that reserved. So this guy has a reserved config, reserved gyro. So we have reserved. Well, this will be a little confusing, I believe. I'm not sure, but I believe it should resolve the issue. Well, it did resolve the issue, but I'm not sure how we can later on. Okay, let's see. Yeah, because there's no way which reserve we are calling, right? Because if it was an object oriented kind of thing, we could have just defined, okay, I'm using this from this one. So actually, I'm just gonna copy these three cases over here, add it over here, okay, and just copy this guy, add it over here. Then what do we need is copy this. Wait a second. This. My bad. Okay, this. Uh, delete and add this. Now I can just delete this guy. This is the get. Uh, my bad. Copy paste. Copy paste. And now I just need gyro config over here and delete this one. I need ACCL config over here and delete this. So now I'm just gonna remove these comments. Okay. I have this one. So to set the uh, sleep flag of this sensor, by default, it should do nothing. I don't want it to create any other issues. So give me a second. I do have to check my email for some reason. Mm, let's see. Oh God. Ah. Okay. Let's continue. Let's continue. Let's continue. I am having a good flow in a way, some way, somewhere. Okay. So what we need is change. I wanted to put the get change bit underneath the get bit actually. Set bit, change bit, whatever. Over here. Okay, so get, change, and send. Now I can copy this buddy Well, no, wait. I can copy this buddy, paste it over here. Okay. Now wait. I can copy this buddy. I want to copy without any comments. So I can just take this guy from here, paste it over here. Now what I need to do is just change this section and I can delete this one. Wait a second, my bad. I will paste two more times over here. Delete this one. And we do the same here. So what I did, I will tell you. We just copy pasted. We are just setting the second date. So this is an array. The zeroth position is basically our address, and the second position is basically our config. So now I do need to change this one as well, as we are trying to write it to the config register, and that's done. So we have done these things. I can try to ask our AI to optimize it somehow. Let's see how he will help us. Let's see how our AI is gonna try and optimize this guy. Okay, void write register. Okay, address and value. So okay, like looks like good actually. Actually, it will work. So let's try to understand the explanation as the given code can be optimized by reducing the redundancy in the switch case block. In all cases, the same three operation are performed. Okay, setting sample temperature temp data temporary data to the case value, setting temp data one to the specific member of the ticket. Okay, this is actually good in a way. We are trying to reduce the redundancy by creating a function that performs internally. So it's a local function which we are creating. So I believe this should be not an I can just implement it without any worries directly. And it's an internal function, so I can actually call this function anywhere else. If you see, okay, config pa, pa, pa. Mm, I would like to change it to this guy. Uh, what's the problem, boy? Okay, wait. Declaring complete with previous right register. What? Config register address. Wait a second. Without doing any further experiments, let's just try and compile it first, because I believe our compiler is trying getting a little confusion. Okay, so this is a local function, and I want this function to utilize. Oh, okay. Okay, I understand. No issues. hmm So if I try to do the same thing over here, okay, like What's gonna happen? Let's see. It should give an error. Yeah, it did because I can't actually call this function anywhere else because this function is local to this function only. So that's in a way good. Let's try and optimize this one as well. Let's see how it will optimize this section of the code. Okay, optimize. Okay, redundancy. So what it is trying to say is, okay. Well, it will be much easier to understand, right? If I'm using this code because this is quite long, and this one has one single function which we are using for an if condition, and that way we can actually check. Let me just okay. We are just oh okay. Well, we can also use it directly, but I would like to compile it first and check. My bad. Compile. Okay, good. Okay, good. Okay. Let's do the same thing with the get register. I believe it will do the same thing for this guy as well. Genie, optimize. So this guy is doing something. Okay, what did he do? Just let me understand. Uh, it's the same thing, right? So I believe I can leave this particular function as it is. There is no need for it to be changed. Whereas for this one, it was quite understandable as we are adding if condition for each and everything. So yeah, I wonder. This is fine. Okay, what are there some restart for the extensions? I would actually do a VS Code restart instead of this. Reload window best. Actually, I would like to disable this guy for this particular. Where did it go? Uh, can I disable an extension for this particular this ESP disable workspace? Let's go. Nice. It won't reload all every time. So okay, nice. So where is the issue? What is the problem? Mm-hmm. So it is expecting something like this. Is it? Nope. Okay. It shouldn't be an issue, actually. Hmm. Even though if it is saying this guy, this thing, so what can I do? Hi, buddy. What you doing? What's MPU 6500? So, MPU 6500 is an sensor which has been used in a lot of places. Okay. So, first place you can find easily is inside your cell phones. There is an sensor called as accelerometer, and a gyroscope, which we use in the cell phone to detect the motion when you play a game. The gesture detection and everything is been done with the sensors. So this is a small guy over here. This is a sensor module, you could say. Let me try and focus this, zoom this a little bit inwards. Uh, so this guy is responsible for. Wait a second. I accidentally turned it off. So this small chip is responsible for detecting the motion, and it does not always give you a direct output. Now let me zoom it out. So it always doesn't give an proper output. So we have to interface it with a microcontroller or a processor, and we write some code, and then we get a value out of it. So I'm just writing a thanks for the subscription. Thank you to subscribing to my channel. Thanks a lot. So yeah, I am trying to right now do an make a library because a lot of developer use this sensors, and it is quite difficult to find a proper one where you have all the things. A lot of libraries ask for basic usage, so I'm trying to make a thing for everyone, you could say. Sorry. Yeah, that's what I am doing right now. So coding is fun in a way because now there are a lot of AI integration. You can use a lot of extensions, a lot of plugins to actually incorporate AI tools for more productivity. Actually, instead of asking the AI to write the whole code, you just write the code and try ask the AI to optimize, understand how and why it is optimizing, so you understand what logic he is using, and what then you actually understand and grow more. But yeah, MPU 6500 is a sensor which I'm trying to write code for. mm, Done this. Good. We have four registers which we can configure. Now we have an optional register as interrupt pin config. So let's make an interrupt pin config. We have four more register to work on, so I'm just gonna do four times. Go back and int, sorry, my bad, int underscore pin underscore c onfig. Then we have int underscore enable enable. Then we have int underscore status. Then we have acc underscore inte underscore ctrl. Okay, so there are quite some things we can do this. Oh, okay. Let's get started. Hmm. So we have interrupt status. I do need to check the register map for this. Where do we have interrupt over here? So we are gonna do this ACCL Intel control. ACCL Intel control. Do we have user control? Did we do user control? My bad. Wait a minute. Let me check. Oh damn! Wait. Ah, I missed one. User control. This is important. USER underscore CTRL. So let me drop this down. 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 And then we have this big guy. We have a structure over here. USER user CTRL bitmap. So in user control bitmap, what do we have? The seventh position. I want zero signal con reset. Okay, then we have I2C mask. As actually we are not actually using I2C, so we won't be actually using these bits, but we do need to keep as it is a bitmap in a I'm creating. So and FIFO enable, DMP enable. Okay, nice, done. Now I can create couple of. Wait, I just need to make it here. No, not here. Okay, good. Whew. Now what else? What else? What else? What else? We have these three int pin config. Int pin config. We have int pin config, and I'm just gonna go to 55. 55 int pin config. We have a lot of different things over here. We have reserved DM. We got reserved at the very beginning. I'm just gonna copy this guy, paste it over here, and just say int pin. Then we have bypass enable, bypass enable fsync interrupt mode enable ACTL enable fsync enable. I don't know what is this. Interrupt status cleared if any read operation is performed. Am I? Yeah. Let's int pin open ACT. I am not sure if open will create an issue. Yeah, I thought so. We have an issue with FIFO enable. Where is this guy located? FIFO enable. I need to find this guy. FIFO enable number 2. FIFO enable. User control bit map. Enable bit. So this is how I'm gonna just change this issue. Now I hope there is no issue with open. I hope that's good. Okay, now we are done with this guy. We can go to interrupt enable. Interrupt enable. Down int en enable. Interrupt enable. We have the GG on me actually. There are two reserved. So reserved int underscore one underscore two fsync interrupt. Fsync interrupt enable. Then we have p flow control, and then we have again number 3 whom, and we have the last bit as well as reserved, and I can clear all the rest of these. Okay, sorry. Haha. Int status, and we have raw data ready. Int dmp, and I believe this will create an issue. uh STAD status one. Well, I should actually just remove the reserve and solidify the enum value. I guess that would be the actual best idea to do. So I don't create a lot of reserved names actually. Okay, let's continue. DMP equals to 0 equals to 1. I don't want reserve, so I just remove the reserved. Fsync interrupt. Fsync interrupt. This will be 3. Fee overflow interrupt. FIFO overflow interrupt is equal to 4 if I'm not wrong. Then we have 6. Who? Ah, yes. Damn. What should I say? Copy paste, and then here we go equals to 6, and we have, yep, this is what I wanted. Now we just remove the interrupt reserve control F. Okay, first of all we just add 0 1 2 3 4 5 6, and I am gonna remove this, this too. So no one needs to worry about actually changing that particular bit because we have to configure only these ones. Equals to 1, equals to 2, 3, the rest of the place I don't mind. The only place where there is a reserve, I don't care. Well, this was easy. I need to add 0, 1, equal to 3, 4, 5, 6, 7. Remove this guy. I don't care about the last one. So this is good actually. Nice. So we just do a simple compile. Nice. Now we just add a couple of more cases. 1, 2, 3, 4, 5. US user control. Okay. Dot US user control. User control. Get register. Then we have int underscore pin config, int pin config, int pin config. Then we have int underscore enable. We use int enable, int enable. Good. Then we have int underscore status, int status, int status. Actually, did we write ACCL Intel control? Well, I did. Yeah, but I forgot it to make and do this one. So we create a new one. But I'm just gonna make it ACCL um, Intel control, ACCL Intel control, ACCL Intel control. Okay. Oh damn. Wait. Yeah, this is good. Close down this function. I'm gonna make an CL INTL CTRL. So what do we have with this register? ACCL Intel control. Oh damn, we have 0, 1, 2, 3, 4, 5 bit as a reserve bit. So we have 6 and 7 bit only. 6 bit and the seventh bit. So here we go. It was very easy actually. Do we have more? We have signal path reset. Mm, well, I might have to create this. Let me check. I have register addresses, signal path reset. Yep, I have added. So let's create one for this one as well. Signal path reset. So we have temp reset as 0. Okay, then we have ACCL reset as 1 and gyro reset as 2, and that's it. We don't have anything else, so I do have to make a u and u and 8. What was it? SIGNL signal path reset. That's it. I will ask our AI, maybe it can like somehow optimize for something. Not sure. Okay. I do need to understand this thing. So I'll just do on STM32. Oh, okay, I guess that would be actually great. Mhm. Okay, what was I doing? Signal path reset. So get SIG signal path reset, signal path reset, signal path reset. Go like this way, like user can actually directly use the value directly from the inside of the structure, so there shouldn't be an issue. Now to get back on. Just a second. Sorry for the sudden interruption. I'm just sending a picture to my colleague regarding something. Okay, so let's continue. Okay, so we are done with the register get bit. Now we get on this thing. So we have USCR control, USCR, USCR. The hell? Uh, Ooh, do I need to do it like this? Well, this might be an issue. I guess if I make it like this, maybe that's a good idea. Oh, then I have to add more of the shit. Okay. Hmm. Give me a second. I'll change that again. User control. Yeah. Then we have int underscore pin config and pin config and enable and enable and status and status and last one should be CL underscore ntl. We have, wait a second, intel control ACCL intel control ACL config. Do we have anything else? No. Then we have this here into control, and now I can just cut paste inside this guy, and I believe it shouldn't create an issue. No issues as for now. Mm, what is the issue? Hmm. Is there an issue? How come there's an issue? Huh? Okay, wait a second. Let me check. Let me check. Okay, now this guy is creating a damn bullshit. Okay, but okay, whatever. Didn't I? The hell? Uh, not settings. Workspace setting. Extension. C plus plus. Format. Modify. Uh, inline. Use inline view when space is limited. Not, no, 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 no. Is it on? Uh, inlay, in, inlay, 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 Damn these people. Hide leading score. Display suppress parameter name hints when the suggestion inlay hints show space. Auto declaration enable. Wait a second. Let me reload this window. Are you guys dumb? Uh, extension feature C plus plus. I'm not displaying this. I'm not displaying this. Inline parameter hide leading Okay, I'm gonna kill this. Okay, because this workspace is not saved, I guess. Uh, save. And what if I want to enable it over here and over here? Now this dumb thing works properly. Now this dumb thing works properly. I'm gonna kill this bird. Okay. Oh, now let's get ahead. What is the next thing? Is to Ooh, my bad. Sorry. Is to send the data, and from what I understand, we just put this guy here. Take this guy, put it here. Okay. Now, what is the dumbest issue? My bad. Let ask our AI because I don't want to ruin my brain anymore. So we make multiple of this case. This over here. USCR user control D underscore pin config and pin config enable enable status status. I see. ACCL underscore NTL config config done. This section I just copy and paste it over here. Now I have to ask this guy to optimize this. No, brother, it is not sequential. Is not. You dumb person, why can't you just use my older, not this chart? Yes, now I'm gonna ask this guy to optimize it in this chart. Good. Oh damn. Oh damn. Good. I almost made a mistake. I almost made a mistake. Insert this, control F this. Now inspect everything visually. Take this guy and put it over here. Okay, I have to do the same thing over here. Dumb thing. I'm just gonna ask this guy to not complete the code. Uh, Add comments. Thank you, but I want a toxic comment. So I'm gonna use this guy. Hmm. Good, but lot of different things as brief. Remove this F and remove this down. Here we go. Remove the white space. And looks good to me. Just gonna change this one. Um, let it handle. Ooh. I believe it is adding some comments on the right side. Yes, I thought so. Insert Control F. Nice. I'm just gonna remove this white space. This should be brief and I don't know. Don't damn. I don't want this and don't want this. Good, good, good. Two empty spaces after each function. Insert, empty the white space. Remove this section. Remove this section. Add space and add brief. And this is okay. Two white spaces after each function should suffice. So we have a couple of functions created now. Ah, whew. Ah, I guess I was also trying to initialize setup. So I do want to set the data as a default config p underscore mpu dot flag dot sleep equals to 0x00 not flag p dot not flag dot register dot equal to 0x00. That's the gyro config external range. Well, thank you, but not dot tada 0x00 dot config. Uh, so I'm just gonna copy this section p underscore dot this dot gyro config dot enable dot and status management go. So these are the default values we need to. I'm just gonna set it to. Uh, so I have one question I'm not sure about. I'm just gonna. Uh, let's say I'm just googling some questions. Okay. Usually it reads at zero or sets at zero, so it's fine. And now, what are we supposed to do? Is we are supposed to first in the init mm, reset, and MPU, sorry, register get p underscore mp6500, comma. I would need a USD or user control register. Then in the user control register, I need to change something. The bit to where's the user control register? So in the in it, as we are using 106, I'll show you. So if we are using a SPI mode only, so we need to set this bit. Okay, set this bit, and it should reset automatically after one clock cycle of internal 20 minutes. So technically, actually, I need to implement this thing. I to if disable in write function actually. Mhm. Mm. So I need to check pointer to the not this function actually. My bad. Send register this one. User control. After this is done, I need to change the bit again to reset actually. Uh, First let's user control. Uh, Register change bit p underscore MPU6500, comma. Then we have US here, user control register. Then bit position would be I to C. Wait, what was it? I to C if disable. I to C underscore if this bit state is equal to what was it? Bit set. Then we do this. Okay, but in register.send, I need to call this again to reset the bit because technically after one clock cycle it should reset. So the hell, where did it go? I'm just gonna copy this guy and user control register. I'm just gonna do this and reset, or I can actually after writing the shit I can always sync it up. No, this is fine. I guess. Hmm. The problem is, it's better for me to do something. Uh, uh-huh. Okay, wait a second. And this one only. Where is this? Change bit. Power management, user control. Right. In this change bit, what I do is state. I change the damn state. Oh yeah. Well, I need to think about a way. So, tum tum tum. Let's implement something as to what. Let me check. I need to read the with what position of the bit technically. So I need to check this bit auto clears after one clock cycle of the internal 20 megahertz clock. Only be set when I do see master as this bit is set during an will hang, which will require the host to slave. Whew. We need to check the fourth bit. Let's see. We need to while we send the data. User control. If ampersand p underscore mpu dot register dot user control. Okay, and one to what flag we are looking for is I to c underscore if this right, then we do a for what again I to c underscore if underscore sorry I to c underscore if this uh so first I want to do this. mm, hmm. Okay, um well I'm not again. For all of these. So what I'm gonna do is copy this section, else if but this time I do dmpd set dmpd set. I'm just gonna try and understand what I have implemented, because I'm using my old code to for a reference. Okay. So what is happening is basically we are trying to see if that particular bit is set or not. So by doing this section, okay, this part, this operator use bitwise and to check, okay, bitwise and to check, it shift one, basically the value uh, left how many times, it will do it four times, 0 1 2 3 and 4. Then what we do is it's set, then this operation, shift one left by place essentially creates a number with one at the I2C and zero elsewhere. The result of this of the bitwise AND operation will be either zero or, depending on whether the bit is unset or set respectively. This operation shifts the result right by either place. So if the bit was set, the result will be 1, otherwise it will be 0. This checks whether the result of the previous operation is non-zero. That is, whether the is was set. Okay. Tada tada. So technically, use bitwise and to check if the bit at the position this is in the user control register is set. So, and we do the same thing for rest of the shed, because these guys reset automatically if we in the future we in the person wants to use anything like a resetting shed, it will create an issue. It auto clears, right? So we just need to make sure these dumb things auto clears. Damn, my headphone scared the shit out of me, saying charge complete. Damn. Okay, I just need to create two more because we have this one as well. Before reset this, this, this done. Wait a second. What else? What else? What happened? Da, 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 da. Okay, now do this one as well. If this base is set during does this bit auto clears after one clock cycle. Use this one as well. Da, 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 da. Do this one as well. Signal this bit auto clears after sensor register signal. We have almost half the register in this section. Wait a second, something feels wrong. Okay, now we try and ask this guide to optimize this. In bits, in size, okay, for int I is equal to plus for ta da ta da ta ta da ta da ta da ta da ta. Good. Actually, this is better, I guess. Hmm. Now what is happening over here? P if condition. Let's check the if condition. Okay. It and why the hell? Okay. So the loop is used to go through each bit position for each bit. It checks if it is set in user control. If so, it calls a view change. Mhm. Hey, wait a second. If I have set a lot of shit, my bad. This is gonna be an issue because if I set multiple of this, then it will create a damn issue. Now we can try and ask this dumb people to, my bad, to optimize it. Because if I set two of these bit to reset, then it will create an issue because it will only satisfy the first condition. Why do I feel like it's using the same thing? Tara. Okay. Ah, should I use or should I use this? I don't know anymore. So in and they so they already use a repetition in the code and make it easier to add or remove bit position to check in the future. Um. Hmm. Let's try it out. So can you explain this section? Okay. Fine. I'm a dumb person. I guess it's okay. Did I? Well, I would need to add new comments for this dumb thing. Well, I can't make it way more faster, but I believe it is okay. Da 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 da. I just need to add this. I don't want to add a lot of commands in this section, but let's see. Nope. So we add here one comment and here one comment. So nice. Okay. Whew. Okay. Da, da, da. So I guess I will be done in like next 5-10 minutes. Um. mm, yeah, like as I told, I am feeling a little bit under the weather, so it would be not an issue. My friend message, so it's fine. Da, 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 da. Let me check. Is there anything else I need to think about? Well, I do need to check the other register which we are using if it's gonna reset or not. If it does, I need to do the same thing. See, let's go. Found one, and we have to look it for the other ones as well. Ah, yeah, I'm gonna do this in the next stream, which will be the part 3 of it. And once we have configured all of these, like for now, this much of initialization is enough, as we are uh, defining that this guy should not go and sleep, and we are only defining it to set for SPI communication only. So good for us. and there are a lot of functions. Well, I wonder if I'm able to, let's see, change bit. Let's see if I can use this function. ng change underscore bit. Nope. Good. 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 All right. I will now. I'm gonna end stream now. So I hope you guys enjoyed. I believe you understood somewhat. And if you have any questions or any suggestions regarding the way I'm implementing this code, please do comment your suggestions. And if you have any other topics which I would you look which you would love me to work on, so do comment this the ideas as well. So thank you guys for joining my